a cell is there here. Consider a cell of EMF E and internal resistance R. The current drawn from the cell can be varied. Okay, some output power still same when current drawn is I1 2 ampere. I will proceed in this way. The output power drawn from the cell. So here first it will be current I1 will flow. In the second situation, output power will be for what value of current, the output power will be maximum. That's I'll come to the first. Can we assume something like this? What do you mean by output power? I think this has to be justified here. Is it, shall I write R only or R1, R2? It should be R1, R2. Okay, let's write the further. I'll go for, let me write loop equation. So this will become, I think we know this should be E minus I1 R1 minus I1 R equal to 0. Looking at this circuit, E minus I R2, I2 R2, I2 R2, I2 R equals 0. Let me multiply I1 with this E into I1, I square R1, I1 square R equal to 0. Here E into I2, I2 square R, I2 square R. It's telling output power will be same in both the cases. So what is output power? The output power means I square R1. P out, I'll write it. Okay, almost we are very near to the answer. I1 square, I wrote it. So this output power P naught, what we can write, EI1 minus I1 square R. EI2 minus I2 square R. What is P naught? Output power. Okay, after this, what is the maximum power? When the power will be maximum? In general, okay, for a circuit, okay, we'll take like this. Some current will flow. When the power will be maximum, I think the power will be maximum when load resistance becomes equal to internal resistance. This is the maximum power, no? When the load resistance becomes equal to internal resistance. So now you can ask question, sir, how you can say this is R1, R2? Can it be R? It can be R also. Because I1 output power is same. If it is output power is same, then I1 square R, I2 square R, not possible. So therefore it should be R1, R2 only. Am I right? I think I should justify this. No, this is a maximum power. No? So when the power delivered by the source to the load is maximum, when these two resistances are equal, then what is the formula for that? What is the load current? It should be equal to, I should be equal to E by R plus R or E by 2R. What is this? This is a I naught, we'll call this current. This is a current for which the power delivered by the source to the load will be maximum. Current at which power delivered by source to load is maximum. Who is a source? Is a source. Who is a load? Is a load. For what value of current, the power output will be same. Okay, now, okay, I do have. Okay, how to proceed further now? Somehow, okay, we are able to justify ourselves with some answers like this. Shall we write? We know this I1 plus I2. So what can be I1? Output power from cell is same when the current drawn is I1 2 ampere and I2 8 ampere. For what value of current, the output power will be maximum is telling. I think we are really, we have to look at this particular graph. The graph will come with a lot of information which we have to explore. This is what he mean to say. He's asking this one. So this is one current. Power will be same, no? So let me draw an horizontal line. So there are two values of current at which power will be same. It has to be no, because this was the expression for power. And what is this? This should be equal to x-axis. What it should be equal to current. No, this is power versus current. And for these two currents, the power will be same. And there's a one value of current at which it will be maximum. That is I naught. And what is this value? Okay, it has messed up. I'll come for this one. So this is how much equal to I1. This is what I2. I think this graph, if you would have plotted in the beginning, it would have been much help. There would have been no need of all this thinking that you could have managed here. No necessity of this, but nothing wrong. Students in general, they think like this, R1, R2, let it be. No, come for this graph. You know this one. I think it can happen, no? Because the curve will be like this. Can you remember maximum power? So this is what when the resistance will become equal to internal resistance. This is what I know. How to calculate, we know it. What is I1? We should write. The biggest problem and is telling output power from cell is same and current drawn is I1 and I2. Only that much of information what we have. I think there's only this resistor itself is there. There's nobody is there. Only this resistor is there. So what about this circuit? What you are going to do with this circuit? I don't know. In general, students will think like this. I'll keep it in a corner. Let's see that. Okay, let me look at this part of the right hand side of the discussion. Let's see anything I can make it. So EI. So E is equal to I into R plus R. This much is what we have. how to correlate all these things. Somehow that I1, I2, I0 has to be determined from this much of data. I think it's a purely math based one because now I given a curve. Answer will be 5. We'll substitute the value of R. Value of R where? Rishika?
Equate P naught values, sir.
Okay, we'll get E and R values. Then what is I0? I0 should be E by 2R. Okay. No, this equation 1 and 2, if you equate, okay, we'll see any help. E minus I1 square R equal to E I2 minus I2 square R. So E terms on one side, I1, okay, this one, I'll make it here. I2 square minus I1 square R is equal to E into I2 minus I1. I'll get the value of E by R.
E by R is I1 plus I2.
E by R is
I1 plus I2.
I1 plus I2. So we know I1 plus I2 is how much?
10.
2 plus 8, 10. But I0 is how much?
E by 2R.
E by 2R. So therefore 1 by 2 into E by R. This graph is very important. This discussion what we made very important. Okay, this one. So maximum power can be asked questions of these kind also. You have to be extra alert. The curve is very important. This curve is very important. Please do just analyze anything like this. Questions can be asked with the idea of that curve also. I think the initial what we assumed is really will help us a lot in the numerical. Okay, we'll take the next one now.